Welcome to class. This is Master. In today's class, we're going to be looking at another interesting question. And this question is on differentiation. The question goes, find the derivative of y equals x squared plus 1 all over x minus 1. This can be written as x plus 1 all over x squared plus 1 all over x minus 1. Interestingly, we need to apply the basic formula for differentiation, which says that if y equals to x raised to the power n, then dx equals to this power of n times multiplied by x raised to the power n. The next thing you do, differentiate, difference, minus 1. So this is nx raised to the power n minus 1. So basically, you should know this for differentiation. So in this video, we are going to be differentiating this function. This function will be applying that basic formula, but looking more closely, this function is a quotient. That means that this function has a numerator and has a denominator. So we're going to apply the quotient rule. And the quotient rule says that using quotient rule, we will say that if y equals to u over v, both u and v, they are functions of x. Yes. In bracket x, I'm saying that this is a function of x and v is a function of x. So applying quotient rule, I would say that the y dx will give me v du dx minus u dv dx all over v squared. V du dx minus u dv dx all over v squared. This is quotient rule. Another way you can write quotient rule is this. That dy dx equals to minus u dv dx plus v du dx all over v squared. This that you're seeing here is the same thing as what you are seeing here. So let's proceed. For convenience, I'm going to be using this form to solve that question. So if you look at this question critically, we can say that what is our v and what is our u? Our u is the numerator and v is the denominator, which are both functions of x. So we say that u equals to x squared plus 1. Immediately, let's find the u dx. The u dx means I'm going to differentiate u with respect to x. Don't forget also that y equals to x raised to the power n, that dy dx is what? Nx raised to the power n minus 1. So applying that here, I have differentiating this is 2x raised to the power 2 minus 1, plus differentiating this is 0 times 1x raised to the power 0 minus 1. Alright? So this will be du dx equals to 2x, because 2 minus 1 is 1. And this is 0 times whatever we have there is 0. So du dx is given as 2x. The next is, we will quickly recognize v. V is our denominator, which is So we say that v equals to x minus 1. So immediately we find the v dx. Differentiate v with respect to x. So this is what? This is something as 1. The power here is 1. So this is 1 times x raised to power 1 minus 1. Minus 1 equals to, this is 1 times x raised to power 0 minus O. Again, a constant. When we are differentiating a constant, it gives us 0. Let's correct that. So dv dx is that x raised to power 0, 1 times 1 minus 1. Of course, this is together, alright? So dv dx is equals to 1. Having found dv dx, let us apply what we have gotten into the equation, into the formula. Applying that, we will have that dy dx, that's the derivative, equals to v. Let's not forget what v is. V is x minus 1 times du dx. Let's not forget what du dx is. Du dx is 2x minus u. Let's not forget what u is. U is minus into x squared plus 1. Close the bracket, times dv dx. The value of dv dx that I have here is 1. All over v squared. Don't forget what v is. V is x minus 1. So that's x minus 1 all squared. From there, we are going to simplify the numerator and simplify the denominator. So now that we have the equation, so I can move ahead in wiping that. I just need to keep the options for us so that we can be checking and confirming. So from there, this is the same thing as dy dx gives me x minus 1 into 2x minus into, of course, 1 times that. That will not change. X squared plus 1. No need putting that one because it's 1. Or yes. So all over x minus 1 all squared. 2x will multiply everything inside the bracket. So I have 2x squared minus 2x minus, we open this bracket, this will be minus x squared minus 1 all over x minus 1 all squared. So from there, we are almost there. We will say that dy dx gives us 2x squared minus 2x squared gives me x squared. The next I have is minus 2x. The next I have is minus 1. I'm just putting the like terms together all over x minus 1 all squared. We have a choice to open the bracket in the denominator, but if we compare what we have in the options, alright, there is no simplification. So I would leave it this way. So differentiating this, the answer which I am left with is option C, which is given in the option. Thank you for staying to the end of this video. We will see you in the next class. And master, subscribe, like, and share.